right, students, so in this problem, what we have is benzoic acid is a crystalline powder. It contains 68.8% carbon, 5% hydrogen, and 26.2% oxygen. What is the empirical formula? So what we have to do here is figure out how many carbons, how many hydrogens, and how many oxygens are going to be in this compound. So to do that, when we're starting from percent, I always start with what you're given. And so what we're going to do to figure this out, the best way to do this, we've got to get, remember those subscripts mean the number of something, right? So if you have something like C2H3O2, right, that's 2 carbons, 3 hydrogens, or 2 oxygens. That is a number of something. So that's where I want you to connect that back to moles. We've got to get this somehow, somewhere to moles, because moles are the number of something. And so we can relate the two together. So to get to moles, we're in percent. What we can do is make a weird assumption. We're going to assume that we have 100 grams of this. So if I have 100 grams of this compound, then it would make sense. If I have 100 grams of this compound, this benzoic acid, then I would have 68.8 grams of carbon. I would have 5.00 grams of hydrogen, and I would have 26.2 grams of oxygen. And so then what we're going to do is we're going to take these now, and we should be able to convert these to moles. Just as we said before, that's our goal, to get to moles, the count of something. And so for us to do that, again, this is as straightforward as it may come. We're going to simply divide by molar mass in each of these cases. And so we know, for instance, for carbon, we know there's 12.01 grams of carbon for every mole of carbon. We know for hydrogen, there's 1.01 grams of hydrogen per mole of hydrogen. And then we know that for oxygen, I'm kind of running out of room, so I'm going to rewrite this one a little bit below. So we know for this creature here, we're going to have 16.00 grams of oxygen for every mole of oxygen. So if we do this math, we should get the moles of carbon, of hydrogen, and of oxygen that are in this sample. Welcome back. All right, so we're going to go 16. Divide that by 20.01. So now what we have, some cool stuff. We've got 5.72. Let's see, here we have 5.72, and that's going to be moles of carbon. And then here for hydrogen, it's going to be pretty close to 5, so it's 4.95 moles of hydrogen. Last but certainly not least, we have this creature. So by 16, and that's going to be 1.64 moles of oxygen. How do we get to our empirical formula? We're in the count, how do we do it? Well, again, we're looking, remember that in these formulas, we think of them also as ratios. So if you want to, you can rewrite your compound like this. So we know it's going to be C, it's weird, but we can do this, right? So 5.72, H would be 4.95, it's supposed to be 9. Oxygen, of course, is 1.64. Well, this isn't, we want simple whole number ratios, right? That's what empirical formula is, right? Formula with the simplest ratio in whole numbers. So you can either play around here, or what you can do, and I think the easiest way to get to that answer from right here is easy. You just simply figure out which number is your smallest, which in this case it's obviously the oxygen. And then I'm going to go through and I'm going to divide every single number by the smallest number that you see. So for instance, in all 3 cases, I'm going to multiply every one of them. Remember, these are ratios. So I'm not changing the ratio if I'm dividing them all by the same person. And so if I take 5.72, divide that by 1.64, I'm getting a number right around, it's awfully close to about 3.5. For hydrogen, 4.95, divide that by 1.64. And this number is awfully close to 3. And you'll notice that I'm kind of rounded here. And then oxygen, of course, that should be a perfect 1. And so in doing so, now you can kind of see it's a little bit easier. If you don't get your formula here, I can see, though, what I can do, right? If I just double everybody. So if I just double every single person, we should have 3.5 is 7. That's H6O2. And there it is. That would be the formula for our empirical formula for benzoic acid.